This month, we have a very, very exciting topic. We have the 120 volt energy systems, battery enabled induction stove coming from a fantastic manufacturer that you're going to hear from in a second. We are so excited about today's conversation, and I think it's just a perfect follow-on from last week. And I just want to get it out of the way right now that we did not create the furor over gas stoves last week in order to promote attendance for this webinar today. In no way was that us doing this. But if last week was about the outrage, then today's session is about the awareness. And if last week was about the awakening of the dangers of gas stoves, well, then today we're going to talk about the actions that we can take in order to be able to start to move us towards the clean and resilient electric kitchens that we need for our clean air and climate-friendly future. So my name is Panama Bartholomew. I'm the director of the Building Decarbonization Coalition, and thank you so much for joining us today for the continuation of the gas stove versus electric stove conversation and getting beyond the dangers and into the opportunities ahead of us. So I'm going to actually turn the stage over to our leader of electric kitchens, Noah Cordoba. He is our electric kitchen maven here at BDC. And we're so happy that Noah came on board in the BDC and everything that he's doing around electric kitchens, and highly recommend, if you do any work in the space, to please reach out to Noah for information about training programs for salespeople, for builders, for showroom folks, information on policies at the state and the federal level, everything electric kitchens. Noah is your guy. So please feel free to reach out and work with us here at the BDC on electric kitchens. So thank you all for joining us, for continuing the conversation. And Noah, take it away.
Amazing. Well, thank you, Panama, for those words and the kindness. Hello, everyone. My name is Noah. I'm a Senior Kitchen Electrification Associate with the Building Decarbonization Coalition. We're super excited to introduce the webinar today, focused specifically on Charlie, the 120 volt induction range that's hitting headlines and making everyone so excited, and certainly going to make electrification one step easier for a lot of people. A few things to run through is that I want to say a quick thank you to all of BDC's members who make things like this possible. It's through the support and the partnership that makes our ability to educate audiences on these topics possible. So if you're interested in joining BDC, you can visit buildingdecarb.org/join. We're super excited to announce that we've recently updated our membership program. So a lot of our resources that previously were behind a paywall are now free, including our policy calls and the entirety of our resource library. The resource library is where we'll be posting the recording of this webinar today, so you can view it time and time again to study up on everything that you missed during it. We also welcome people to consider joining us as trailblazers to become supporters of BDC and work more closely with our teams. BDC works generally to decarbonize building by working to stop the expansion of the gas network, support market development and technologies like a 120 volt induction stove to help advance decarbonization and make things quicker, and set fossil fuel phase out dates for the sale of appliances and different dates for different types of regulations and measures like health standards and things of that sort. We are guided by goals through our roadmap focused on building customer, builder, contractor, and policymaker awareness around decarbonization and interest, ensuring that people who are interested in decarbonization and go down the path receive good value from adopting the measures that we're so invested in, ensuring that building decarbonization provides better value to the builders and contractors that are doing it than fossil fuel heating, and that we're preparing supply chains, ensuring that delivery agents are ready to meet the rising demand for carbon-free buildings that we're all trying to build right now and that we're seeing come up over and over through policy and consumer excitement. and that we're aligning policies to meet other goals that support decarbonization. A few webinar logistics are that everyone's currently muted. We ask that you ask your questions in the chat, and that we will post those to the speaker, or they'll have an opportunity for Weldon himself to answer them throughout the presentation or at the end. Like I mentioned, this webinar is being recorded and will be placed in our resource library afterwards, so it will be free to access and available for everyone. And we welcome you to join us as members of BTC. As mentioned, we have our free membership level, and you can learn more at buildingdecarb.org/join. So we're here to talk about Charlie, which is the 120 volt induction range. I'm super excited to welcome Weldon Kennedy from Channing Street Copper Company, who is the inventor and creator and evangelist for Charlie himself. I don't know if Charlie has a gender. I'll take that back. Weldon is a campaigner and entrepreneur committed to making a difference on justice, equality, and sustainability. He's had experience working in political campaigns across the US and the UK, mobilized millions of people for petition signatures on behalf of advocacy organizations, and built the world's first climate neutral certified running shoe brand, Enda. He's currently the co-founder and leads business development for the Channing Street Copper Company, helping to introduce energy storage equipped appliances to the world. So I'm excited to introduce Weldon, and I will stop sharing and let him take over.
Thanks, Noah. Thanks for having me, and hello, everyone. It's exciting to be here. I'm Weldon Kennedy. If you want to talk about me in third person, he, him pronouns. I want to tell you a little bit of story about how I came to this work and why I think it's important. So early on in the pandemic, kind of May 2020, I'm out on a run with a friend of mine. And that morning I had read the news that the emissions reductions seen in April 2020, that was the rate of emissions reductions we needed to see to hit 1.5 degrees warming. And I was crushed, just absolutely devastated. And I was in a dark place. I saw around me in Nairobi, in Kenya, I saw suffering, I saw starvation, because the absolute shutdown of the economy really caused immense hardship in an environment like that. And the story that I was basically reading in the news was, this is what we needed to do. This is the future that we needed to create to have a sustainable planet. And I saw the suffering, and like the choice is either we burn ourselves or we cause this massive suffering to get there. And I was in a dark place. And a mate of mine who I was on a run with, who works at UNEP, very thankfully, the right running partner to have that day, said to me, well, we've got one planet. What are you going to do about it? And he was actually right. And we got to do everything we can about it. When I got back to the US, I found that all that doom was misplaced. I got in an electric vehicle and I found driving is better. Now I started riding my bike a lot more, and lo and behold, I felt better. I was happier, and it turns out I'm not alone. People who walk and cycle to commute end up being happier people. When you eat a larger plant-based diet, you live longer, you're happier, healthier. And I kind of realized that all the technology exists. Everything is there for us to live better, happier, more fulfilled lives by fighting climate change. This is not a game of sacrifice and suffering. This is a game of making our lives better and fighting climate change. And so that's great. And so I am part of the Channing Street Copper Company because that is what we're doing here. We're making energy storage equipped appliances that make people's lives better while decarbonizing the home environment. So before I get into talking about what we do and talking about Charlie here, Charlie can be a he or a she or a they. We chose it as a gender neutral name. Mostly as representative of a third letter of the alphabet, since it's the third version of this. But before we get into talking about Charlie, I want to ask a couple of questions, if I could. So first, have you cooked on induction? Just want to get a sense of audience here. Who here has cooked on induction? Have you cooked on induction? Yes or no? And then second question, do you have energy storage in your home? I'm going to be like looking at the screen here because I'm super interested to see what the results here are. And see what people say of, have you cooked on induction and do you have energy storage in your home? And we'll just give it like a couple more seconds. Pretty straightforward questions. Hopefully they're easy yes or no's. If there's any gray answer on if you've cooked on induction, that would be interesting. All right, should we close it off? Can we see poll results? What's it look like? Okay, so about 2/3 have cooked on induction, and the overwhelming majority have no energy storage in their home. Wow, okay, really interesting results. I find that super fascinating, particularly that 1/3 of the folks here have not cooked on induction. The good news for that third who hasn't cooked on induction, there's a magical technology out there that is like just waiting for you, and it's great. So like you've got a really exciting thing in your future, and that's, I mean, isn't that a beautiful thing to think about, that like there's just something really cool that you know about that you have the opportunity with a low barrier of entry to interact with. That's exciting. Hopefully it makes your day exciting and tomorrow exciting as well for you. So here at the Channing Street Copper Company, we want to solve both those problems. We want to answer both those questions in the affirmative. And we're doing it with energy storage equipped appliances. Now, if anyone could tell me the process of how you install an induction range in a home, maybe we can just get like one person to like raise their hand, and like, can we call on first person with a hand raised to say, what's the process of installing an induction range in a home?
We're seeing some words in the chat about
In the chat,
Why
raise a hand. Someone don't be shy.
in?
I want to hear your voice. I want to see. Tell me your story of how you think you install an induction range.
Paul, would you like to speak on it? Feel free to come off mute.
Sure. I think there's a big question, which is, what did you have there first? If you have a gas stove, you need to look at your electrical supply. If you have an electric stove, it quite possibly can slot right in depending on what the electric stove is. Mm-hmm. If it's a gas stove, it's a lot more complex if you need to upgrade your panel, if you need to run the 240 umpty-ump amp line.
Yeah, I love that answer, because it's exactly the level of complexity that is the problem. The answer is there is no answer, right? Like it's the only answer is to how do you install an induction range is there are a number of variables that must be considered. In many cases, you're going to need to have at least one expert visit your home to tell you how you're going to install your induction range. Now, energy storage equipped appliances answer that question with a very simple answer. You plug it in. That's it. That's how you install an energy storage equipped induction range. You plug it in. So the difference here with Charlie, and I'm going to step out of the camera here and give you a kind of full down view. This one has its battery tray open so it can be displayed for everybody. And let me get down next to Charlie here. So an energy and storage equipped induction range is an induction cooktop. This is a 4 kilowatt burner, 3200, two 1800 watt inductors in the back. 6.3 foot cubic oven, so a very large oven. I mean, get 3-4 racks of cookies in here if you're into that game, or a giant turkey if you really want to impress the family. And then down here, we have 4 kilowatt hours of lithium iron phosphate batteries. So what happens with an energy storage equipped appliance is you can just take out a gas range, plug into a 120 volt, and that's why this is in their title, they refer to this as a 120 volt range. You just plug into that normal wall outlet, the battery charges up, and then delivers the full power that you need to run a premium induction experience, right? So even though in the title there, it's labeled as a 120 volt induction range, this is actually an 11 kilowatt induction range, right? It has the full power potential as if it were plugged into a 240 at 40 amps. You're getting that full power experience of induction, that beautiful high power, quick cook, the great big solid oven with, you know, that steady temperature that electric is able to provide. You get that experience with a battery. Plus, you get all sorts of additional benefits because you have a battery. One, you're load shifting by default. So you're here in California, you're charging up when the sun is shining, and then you're using that juice in the evening to cook, right? So you're providing grid services and helping all of us transition to a more renewable energy because it's using grid support and flattening that out, flattening that kind of bump in the duck curve in the evening. So that's great. And then two, you have an electric range that works when the power goes out. one of the big whataboutisms that I hear all the time when people say, oh, but my gas range works when the power goes out. It's like, well, actually, first of all, if you were in Texas during the big freeze, no, it didn't, because the gas lines broke. So yeah, I had family that were stuck in that, and the answer is their gas lines didn't work. But this guy would. Charlie absolutely would. It's got that big old battery. 4 kilowatt hours will get you through multiple meals. If you say, hey, when the power goes out, I want to roast a turkey and cook a full Thanksgiving dinner, you'll be stressing that battery a bit. If you say, hey, I want to be able to cook for a family of 3 or 4 meals of moderate size, yeah, absolutely. The stove will take care of that. Plus, I can't see it, it's all the way in the back. There's on this one, an auxiliary outlet, right? So you can go ahead and plug your fridge into it when the power is out. Or, if you don't have anything you're worried about in the fridge, plug in your blender, make margaritas, have a party, the power's out, might as well have some fun with it, right? So it provides not just the resiliency that a gas stove would provide in a power outage, but more. That's the thing about energy storage equipped induction. It's not really the same thing as an induction stove. It's so much more because it provides those benefits above and beyond in categories that other electric stoves can't touch. So that's really one of the joys of including energy storage in this whole thing. So let me talk a little bit about some of the different components that you're going to see here. So induction, hopefully, so the majority of you have cooked on induction. For those of you who haven't, what induction is a series of electromagnetic coils that are underneath this glass cooktop here. They provide a current and vibrate the iron molecules in the pans on the cooktop. That then heats the pan directly, and you get this incredible direct instantaneous heat, right? So you have an incredibly precise, incredibly powerful way of cooking on this cooktop. Then you have the oven here, is a normal resistance electric oven. This guy holds a resistance electric ovens. If you've ever cooked with them, they hold a really steady temperature. They're much better than gas ovens. And in fact, you'll see a lot of the high-end gas cooktop stoves have electric ovens built in because that's the better oven experience than a gas oven in most cases. And then the bottom down there, the lithium iron phosphate battery. So we're used to batteries that are lithium ion batteries because I would say most times that we're using a battery, it's about energy portability, right? We want to take our laptop with us. We want to drive our car. We want to carry our phone in our pocket. And so it's about having high energy density in a lightweight package. And that's what lithium ion batteries do. And that's why they're everywhere. Lithium iron phosphate is not lightweight. You would not put this in your pocket. This battery weighs 70 pounds. The most common application you see for lithium iron phosphate batteries is in server racks. So like, when you need backup power for a server system, it's a big heavy battery that sits still the whole time. It works in cold environments really well. Those servers are often very well refrigerated to keep them cool. And so that's the type of battery that we're using here. It's incredibly stable. If you damage the battery, it never experiences any thermal runaway issues. It doesn't ever catch fire. It'll get hot, but it won't burn up like a lithium ion battery would. And then also it's very stable for long cycle times. So we've all experienced kind of cell phone battery degradation, right? Where after a couple of years, your phone's just not as good. Lithium ion's a short, couple thousand cycles. Lithium iron phosphate is 8,000 to 10,000 cycles. So you're talking, almost an order of magnitude longer lifespan. So we're warranting the stove for 10 years, but we expect the batteries to be lasting roughly 20 years. And we have the ability to swap them out. If you need to, you can just kind of pull one out and pop the next one in, which is great. And one of the next big whataboutisms when everyone talks about battery is, what about cobalt in the DRC? There's no cobalt in lithium iron phosphate, right? So a lot of the worst problems that you encounter with batteries are solved by using a different battery chemistry. So that's a little bit about the stove and energy storage equipped appliances. Where we are as a company in making these things. So we started with the Department of Energy grant and did some of the fundamental research necessary to drive an induction cooktop off of DC power from the battery. We got to that point in basically kind of August or so. Started building out the effective prototypes that we can start doing demonstrations. We've been taking them out to farmers markets here in Berkeley. We've been having folks around to the office, to have lunch with us to try out the ranges themselves. And in fact, we have a lunch starting in a little bit. So if someone comes in here and pops some stuff in the oven, you'll know what's up. Because this model is, they're like almost always kind of different ranges here, almost always being cycled through, and we're always using them and always testing them out. So we've got those going. We've now taken some pre-orders on some initial Charlie models. So these are going to be shipping out. The first ones of these will be installed in folks' homes in the springtime, so in April or so. And then scaling production from there, starting to ramp up. All of these ones are going to be produced in house here in Berkeley, but then we'll be taking that production and taking it bigger from there. So yeah, that's a little bit about where we are. Charlie, yeah, and I guess at that point I would turn it over and say, any questions? I mean, hopefully there's questions, and I would love to answer anything and everything that you might have.
Amazing. Thank you so much, Roland, for that. As you can imagine, there are no questions. I'm kidding. There are so many questions as people are so interested. And so I've been noting down some of them, but I encourage people to continue to ask in the chat, and I will try to do our best to make sure we don't miss any. There was a lot of questions at the outset about battery length, essentially, like how long does it last? I know that can be very variable. Can you speak a little bit more to the battery length?
Yeah, so I'll answer that question in two ways. One, the kind of cooking experience, and one, like the life cycle of the battery in total. So on the cooking experience, when you're heating up the oven or like bringing a giant pot of mashed potatoes to boil, right? You're boiling like 7 pounds of potatoes. This is something we've done a couple times here. When you're heating it up, you're drawing from the battery, right? You're drawing a lot of power. The big inductor is 4,000 watts, which is obviously more than what the wall can provide at any time. When you're heating up the oven, it's drawing a lot of power, more than the wall can provide at any time. But then once you get up to temperature and the oven is holding temperature, or you get up to boil and you just want to hold a boil, actually the power requirements come right down. And so, like, for example, we roasted a goose for Thanksgiving, and you see this kind of draw on the battery. The battery starts like having a little bit of a dip in it because we're cooking some stuff on the cooktop as well. And then once the oven, I think we were doing it 425. Once it gets up to temperature, actually the oven levels off and the power starts charging the battery back up. So the answer that we've come to on this is, if you are really stressing the oven and you're cooking a lot of stuff on the cooktop simultaneously and having at it, roughly 8 hours of cook time is what you should expect if you're going nonstop. That's a lot. That's a real, I mean, so there are edge cases where it is possible to say you're gonna bump up against the boundary of the battery. It is nonstop, very heavy duty cooking throughout the course of the day. If the power is out, I would say kind of moderate cooking would be around 4 hours. If you were not charging the battery, you'd get about 4 hours of kind of moderate use cook time. And when I say moderate use, I mean, a couple of pans, maybe 3 pans on the hob at the same time, right? So like preparing a meal for a family of 4 on the cooktop. So the answer is, like, when you're plugged in and it is charging, a day. And then when it's not plugged in, you get 4 hours. So if the power is out, you have, like, a fairly good chunk of cooking time, of active cooking time to go by. And then the kind of part 2 of that answer is, what's a life cycle of the battery? What's its total lifespan? Again, we'd expect roughly 20 years if you're 8,000 to 10,000 cycles. And if you're fully cycling the battery every day, which you probably aren't, but let's say you are, say you're going heavy duty cycling, then that should be just shy of 20 years. So a really long life cycle of the battery.
Amazing, thank you so much. Some questions on the electrical involved with it, specifically with the battery and with charging and grid integration. So what's the draw on a 120 volt circuit? And is there, can you set like specific hours for battery charging? And does it have the ability to do time-based load shifting based on grid conditions? Does it have any smart functionality related to charging? Yes,
answer to both questions. Yeah, so the maximum you can really draw is 1,500 watts at a given time from a wall outlet. So that's kind of peak draw. In terms of the load shifting capability, we have kind of a default setting, which we call community resilience. And in community resilience, you are load shifting by default. So where the first stoves are all going to be deployed in the Bay Area here. And so that means charging up when the sun is shining, and then really not charging kind of 4 to 9 p.m. For the most part. So load shifting is kind of default to get to as its default position. But that can be adjusted, obviously, based on carbon intensity of the grid, depending on where you are. So if you're in Texas and the wind's blowing super hard at 6 p.m., great charge at that time, right? That's a very different experience than what you have on the grid where I'm standing right now here in Berkeley, California. So that's kind of part one of the question. There was a part two on battery intelligence.
Yeah, does it use any like grid condition data to choose when, or is it specific to the Bay Area in this case?
Yeah, these first ones are specific to the Bay Area because they're going to be deployed here. But as we broaden that out, there is an API that is available that looks at carbon intensity of the grid, and that's going to be our kind of go-to in terms of what to utilize. We can also, in emergency, so long as the stove is hooked up to Wi-Fi, communicate with it to tell it to not charge any grid. There is a user setting where you can override that. We call it, so there's community resilience, in which you are load shifting by default, and then there's individual resilience, which is basically keep the battery topped up all the time, right? So you're in a place where you are nervous that the power might go out. You can turn off that load shifting capability and just keep that battery topped up.
Amazing. Another technical question, kind of a two-part. I think you addressed this, but do the elements and the oven, induction elements in the oven, use AC or DC electricity for power? And then is there an onboard inverter?
No and yes. The appliance itself is driven off of DC that goes straight from the battery. There is an inverter to provide the auxiliary power for it. So the size of the inverter you would need to drive a 240 volt 40 amp experience would be a giant freaking inverter. We have some around. I'm trying to look if we have one within eye line of me now, but they're big. And so no, that inverter is not present, but a small inverter to power basically a wall outlet to power a 110 outlet as an auxiliary port to plug into, that is present on the device.
Great. And then a lot of questions around the battery and safety within proximity to the range and heat.
Yeah.
So just questions around, is the battery safe, and is there any fire concerns around just having the battery near the oven space?
Yeah, good question. The answer is it's very safe. So we've insulated the whole thing, like wrapped it all in insulation, cranked everything up as high as we could go to try to see how hot we could get the battery compartment. And the answer there was it got to about like 80 Fahrenheit. And that's when like us containing all the heat in. The oven itself and the whole thing is incredibly well insulated to isolate heat from the battery and from everything around it. If it wasn't, A, you would have an incredibly inefficient stove. B, you would be worried about your wood cabinetry that's probably bumping up against your oven anyway. And like with dust balls and everything around it. So like, you know, the dust balls are much more likely to catch fire than anything else. So the product is incredibly well insulated and everything to isolate the battery from any heat. The second thing is, again, like lithium iron phosphate is incredibly tolerant and doesn't get as hot, doesn't have some of those thermal things that you experience with lithium ion. The battery compartment is vented to keep the battery at like a moderate temperature. If it's say like 100 degrees in your house, then the battery can have venting, just a small fan. It doesn't need a ton. But yeah, it is incredibly well isolated from the oven and from any heat that you experience. Yeah, and that is something that like we were wondering initially as well, since a lot of times those are used as warming drawers, and it turns out those warming drawers are actually a separate element. It's a separate heating element, and those are used as a proofing drawer. It is because the oven itself is very well insulated.
Amazing, super exciting. A lot of curiosity around what's happening for copper. So there's this range which is kind of the intro, and people are interested. Are there considerations around a cheaper low end unit, and is there going to be maybe a 40-inch model? And you know, what are
40-inch? Someone's got a nice kitchen.
Or yeah, I guess maybe maybe not 40, maybe 30.
Oh no, I'm jealous of their 40-inch range. That sounds nice. 36 is probably next. So you know, 24 is kind of the ADU size or the small size apartment size. 30 is the most common form factor on the market, and then 36 is kind of the first step into the luxury experience or the kind of more premium experience. So 36 is probably next for us. in terms of affordability, it's a really interesting question. For a large number of people, energy storage equipped induction is going to be the most affordable way for them to get induction. So even though this is relatively a luxury appliance, right? Like it's a very nice stove, it is gonna be for a lot of people the cheapest because of that install. And to go back to that question I asked of like, how do you determine how much it is? To even answer the question of what it's going to cost you to install an induction in your house, sometimes you can be out a couple $100 to answer that question. And it goes up from there, right? If you're getting an upgrade on your service, say you have a buried line, upgrade on your service, need a new panel, maybe have to relocate your panel because it's near your gas main, or it's like on next to the property line and that's no longer up to code. You're going through a masonry wall and you're running 240 around your house to the stove, $20,000, right? Like what I just described there could be $25,000, right? And that is like not implausible as an answer. So for someone like that, even though this isn't a nice high-end unit, retail price $6,000, it's the most affordable way for them to get induction in their home. So I would say when we talk about affordability, that we are in a way that is not the name of our game. We're providing a myriad of much greater benefits, but it just happens because of the difficulties of electrification on traditional induction that actually, okay, this is a more affordable experience. And then yes, getting into 36, the stuff that's a lot more fun, and I think people on this call are probably super into, is thinking about other energy storage equipped appliances. These are great, right? Like last week, Gas Week, Stovegate, whatever you want to call it, right? Like that week, I think showed that the cultural zeitgeist is right, that people are looking at their gas stoves as a villain in their household and are ready to make that transition. And so it's great to be at a place where we're able to provide an electrification solution for that. I think, and my hypothesis would be, that same experience will play out with other devices as well. It will play out with water heating, it will play out with HVAC. And for a lot of people who have harder to electrify homes or harder to electrify buildings, energy storage equipped appliances and other categories will be hugely beneficial as well. So we're also looking at those. If you wandered around the shop here, you'd see heat pump hot water heaters and instant hot water heaters and all sorts of fun stuff that we're looking at and saying, okay, how do we make these work as well?
It's exciting. So the scope is big. The solution have to be bigger, of course.
Yeah, I mean, the first solution is easy and obvious from our perspective, because it's like an immediate improvement in your life. Like getting rid of a gas range and getting an energy storage equipped induction range into your home is like an immediate obvious win in terms of like quality of life improvement. Things like water heating, you don't notice the quality of life improvement as much. It's more of like a billing question that you encounter it on your electricity bill, that it improves your life. So it's that, we didn't play for that first, but obviously there is benefit to be had there as well.
Amazing. Some questions around scaling of fulfillment for Charlie itself. So I know you mentioned spring is when the initial ones are going to the Bay Area, and then later in the year for the rest of the pre-orders. Is scaling at scale, I guess. What's the timeline for that? Is it more the end of 2023 or looking into 24, 25?
Yeah, I mean, look, as fast as we can is the answer. We are currently talking to our contract manufacturing partners and various suppliers about how quickly we can scale. I think the last week showed us that we started off with this thing that we needed to prove what the market is. We need to show people that there's a market for this sort of product. And I think last week, well, the proof is done now, right? Like, and so we are hitting, turning the inductor up to boost, if you will, to get moving as quickly as we can. I would anticipate that we will have additional product or volume rolling out through the later part of this year, with significantly scaled deployment happening next year.
Super exciting. Can't wait for it. Some additional questions around accessibility and especially related to rebates. And I think there's another question that's kind of related, is what's the rationale behind a 4 kilowatt-hour battery size? And in the same question, almost curious, did that have a play into what incentives might be available? And could you speak to what incentives you think will be available on the horizon for Charlie? Yeah.
So very good question. On the 4 kilowatt-hour choice, really that is a product performance question first and foremost. Being able to provide that resiliency and a large degree of load shifting. And also, if you're that person that wants to roast 2 chickens and cook 3 things on the cooktop, we want to provide enough battery that you can simultaneously provide load shifting and cook that meal without worry, right? So it is a product performance question that is first. In terms of benefits that has, yes, the Inflation Reduction Act, the 30% investment tax credit for batteries, energy storage in the home starts at 3 kilowatt hours. So we are over that, which is great. And then other incentives. A lot of the incentives that we see that are the easiest to get are the local incentives. So like here in the Bay Area, there's $750 under BayREN. Then you go up to Sonoma County, and Sonoma Clean Power will give you another $500. Those are like fairly straightforward rebates to go after as a consumer, and something that we intend to do a lot of support on. It's very interesting. I was at a farmer's market doing a demonstration of the pre-Charlie one that's like painted bright blue and yellow for show. I was at the farmer's market showing it off, and I was talking to a guy. He's like, "Oh, I just got induction. I love it. Life is great." I was like, "Oh, sweet, man. And those rebates, huh?" And he's like, "My what?" His retail, from the retailer, from the person who did his installation, and the company that sold him, the company that made the stove, no one mentioned that he was due $750 for getting rid of his gas stove and installing an induction range. We plan to change that. Anyone that gets anywhere near us should know what incentives that they have an opportunity to claim. So yeah, 750 in the Bay Area, where all our first appliances are going out. There's also an income qualified 840 that is available from in the IRA as well for removing a gas range and installing an induction. How those stack, we don't exactly have guidance from Treasury yet. So the Treasury Department is yet to publish that guidance, but we expect that in the coming months. And then that'll make it really clear and very easy to be able to tell people exactly what incentives they are. But kind of the baseline right now, baseline package where I'm standing right now, 750 local, 840 income qualified federal, and then a 30% investment tax credit.
Amazing. So lots of money coming down the pipeline.
Yeah.
Absolutely. Questions around the battery replacement. So thinking about the lifespan of the appliance, there was questions around what does cost look like for battery replacement, and then what's the responsibility look like for making that happen? What's the process? And
if it's within the first 10, if it's in that 10-year warranty, it's us, right? So the cost to the consumer is a big old zero. We come and do it, right? Because we warranty that battery. If it's after that 10 years, it depends on what you want to make a bet on the next 10 years of battery pricing looks like, right? In terms of how much that's going to cost. If the last 10 years of battery pricing is anything to go by, that battery in 10 years will be cheaper than it would be today. But it'd cost a couple $1,000s to do a battery swap after that 10-year window. If we were to take today's pricing, anticipate that the pricing will be lower, and batteries in 10 years in the future will be even cheaper, that someone can get one of those if they need to do a replacement.
Amazing. So covered under the warranty, the battery.
Yeah, within 10 years, yeah, we're the warranty is top to bottom. This thing, if anything goes wrong in 10 years, we're taking care of it. I mean, I think it's something as a new company you kind of have to do too, right? Like we don't have a reputation, and so we need to stand by the products that we want to make. And also from like, look, we're a public benefit corporation, right? Like we are mission driven, and big part of that mission is around climate change. And if you want to talk about climate change, and lifespan of products has to be a consideration. We're not making things that have planned obsolescence windows where we're getting you to replace your stove every 5 years. We want this to last.
Absolutely. That's super comforting, I feel, at least for me, and I hope everyone else. Additional questions around accessibility, especially thinking about financing and lower cost models. Again, is there interest, or are you feeling demand or seeing demand or hearing demand for about like a 24-inch model, or models that would be more appropriate for multifamily developments?
A lot of multifamily has 30-inch. I will say we've done a fair amount of digging on this one and have encountered more 30-inch than 24-inch in multifamily even. I know there are a lot of places, particularly like New York City has a higher concentration of 24. But even there, I was on the phone yesterday with a 500 unit building, and they all have 30 inches, right? So like a lot of buildings have 30-inch units. 24s exist. I'm not like, they're out there for sure. But a lot of affordable housing even has 30-inch units. We haven't we haven't priced out exactly when we would be able to do a 24, but it's, on the roadmap, I would say after the 36. and getting to a place where you are very price competitive on a 24 is a lot harder and demands scale of manufacturing. So it'll be a bit easier when we have the whole system up and running a lot more for scaled manufacturing. Do you want to get in on the oven? Sorry, oh, it's not on, but I told everyone on this call that the oven might be in use. Sorry, everyone. Yeah, as I was saying, the oven's constantly going here. So yeah, the 24 on the roadmap, but not as immediate. In terms of accessibility, one thing that we've been picking away at, and this speaks to like my background doing a lot of social justice work and working with those communities that have been given gas stoves in the past or living in gas stove homes with gas stoves, is there are actually local governments are putting a lot of money and a lot of effort in right now to get those gas stoves out. So we've actually encountered a lot of potential opportunity from local governments actually swapping out the stoves in affordable housing. And again, like our solution for those situations is probably the most affordable for most of them, just because the project complexity of swapping out a gas stove and running new electricals in a multi-unit building is very high. So like when you say considerations on accessibility, in a lot of cases, this is the most affordable way to get a induction range into affordable housing and swap out a gas range.
Cool, thank you. One piece on that is if Copper is considering financing available through directly through the product offering or some other mechanism.
We are not doing financing ourselves, but we'll have a financing partner. So in the same way that like traditional financing works.
Okay, great, good to know. Related to the warranty, I see some questions in the chat about obviously we want to see scale go up and up and up, but on the off chance that Copper is not around in 10 years to fulfill the warranty, is just some questions on who would fulfill it.
Yeah, I mean that's what warranty insurance is there for that, right? That's the thing that you buy. It also covers you if you have some, it's a type of insurance that if everything goes wrong and some huge manufacturing error happens, you need to lean on your warranty insurance. It's a financial product that exists.
Okay, great. I'm trying to see if I saw any other questions that I didn't get to.
Noah, this is Panama.
Yeah.
Saw some good ones about marketing and expansion plan.
Yeah.
So, do you plan to remain direct to consumer, be working with resellers, and how are you planning on getting the word out?
Yeah, good question. Look, I would not describe us as a direct consumer company. I believe, so the third of you that have on this call who've not cooked on induction, I believe when you have that opportunity, you're going to be convinced. And so I want to give, and this group, right? This is the team that is like, we're in. Like we want building decarbonization to happen. And a third of the people on this call have not used induction. I think that really speaks to how most people have encountered induction cooking so far, right? And there's Stephen Colbert the other night like made a joke about like electric stove sucking, and he's like, oh, it takes forever to heat up and then it stays hot forever. And it's like, nah, mate, you haven't used an induction stove, obviously, or even know what it is. And bless him, he has this great opportunity to learn and experience induction. That is not a thing you can provide as a direct consumer company. I can keep going out there to farmers markets, and we'll do this a lot more. We'll keep going out and giving people a chance to interact. That is the direct consumer experience in the format of us giving people an interact. But we got to get into showrooms. We have to be getting into places where people can interact with the product. And so absolutely, we intend to be working with partners, anyone that has a physical presence that gives us an opportunity for people to get hands-on with induction, with energy storage equipped appliances for the first time. We want to be in those spaces. And so, yeah, we're absolutely pursuing that in a variety of forms of partnership.
Absolutely. Yeah, I'd love to see it in a showroom.
Yeah, me too. Working on it.
I see one question about the safety in an EMI certification. Could you speak to certifications that, I'm not fully familiar with that one, but any certifications that were necessary or available for Charlie?
Yeah, so normally everyone's asking about the UL certification. The chassis that this is built on is not a UL certified chassis. So a lot of appliances like this are not even UL certified. We do one of our founders actually wrote a new UL certification at one point in his career, and so like in terms of like testing and certification standards, we've got great depth on that on the team. The current requirements on this is not that it is, but we will pursue one over time. It takes time to go ahead and get that. So we will pursue a UL certification above and beyond actually what the competitors are putting out there. But at this point, it's not a base requirement on a plug-in appliance like this.
Sure. And the EMI, I think it's electromagnetic interference certification. So.
Oh, interesting. No, I've not
Yeah.
encountered a certification around that. I mean, it you know, we have FTC because it is because it does have broadcast. But yeah, that's a fairly straightforward. That is not providing an interference.
Another question on efficiency. What is the efficiency of Charlie compared to a standard 200-volt electric induction stove, given the round trip inefficiencies of charging and discharging? Do you have numbers on overall efficiency?
Yeah, like battery round trip, that you get roughly about 80 to 85% round trip efficiency on the battery usage. So like when you're doing that load shifting, yes, there is you do have a little bit of round trip inefficiency hit there. In terms of like power efficiency and everything, it's right up there. Like in terms of, you still get that 90% cooktop efficiency that you experience with induction. But yeah, the battery round trip inefficiency, you know, you do lose just a couple of percent on that when you're doing that load shifting by default. From our perspective, and our chief scientist has done in-depth emissions analysis on that. The significant benefit there of shifting to being able to use clean renewable energy for cooking, the total carbon benefits potential if we were to deploy these kind of universally would be somewhere in the range of 330 million metric tons. So even with that like round trip efficiency hit from the battery, the carbon savings is significant.
Questions around the communication protocols capable on the unit. I think we've talked a little bit about this with battery and grid integration, good conditions, but are there any communication pieces in like hardware that's installed pre into the unit that could be used for different locations?
They are Wi-Fi enabled. That is, I mean, we don't have that written for like a third-party API or anything though. So it's just us.
Great. And then questions around the market for battery integrated appliances. I know that you mentioned, you know, not the only cooks in the kitchen now. And do you have any concerns, or what are your thoughts on other brands that will come into the space, especially large brands, as they see this as an area where, you know, the market's going to go?
First, I want to say energy storage equipped appliances, and I want to be specific on energy storage equipped because the category is broader than just using batteries. For example, if you use a heat pump to heat a tank of water and then use the energy from that tank of water, that is an energy storage equipped appliance. And I just want to be very specific on that because I think that categorization, it's nascent at the moment, but it will be something that is an important distinction for all of us communicating on this. So the energy storage does not equal battery. It just happens to be, in this case, it is one of the methods of energy storage you're using. So yes, energy storage equipped appliances. What does the market for them look like? Look, there's 40 million gas stoves in America. Given last week, how many of them do you think are going to be retired in the next 10 years? That's the question. And so we see the market as being huge, and we have just an urgent opportunity to go out there and help people improve their cooking experience, have better, more comfortable homes with cleaner air. So that we're going after it.
Sure. Yeah, the market potential is big because there are just simply so many.
Yeah,
Amazing.
Absolutely. And again, that's just the stove. Other energy storage equipped appliances, whether it be energy storage equipped instant hot water heaters or heat pump hot water heaters or HVAC systems, you know, all the way down to the smallest appliances, you know, the Super Boost microwave. All of these things have significant opportunity to improve people's lives. So we'll be looking at those next.
Sure. I'm going through, seeing any last questions. I did see a question, I think this came up before. Do you have a partnership with LG related to this product?
We don't. We are using LG chassis to build on. So this is an LG chassis that you see behind me here that this is built on, but everything, all the electronic controls and everything are out of it. Those are our electronic controls in it. We don't have a partnership with any other manufacturer at this point.
Zachary asks, are you using a capacitor in your design?
I don't know the answer to that question. Sorry, I can't speak to all the exact electronic controls on the inside.
Sure.
I can't say I know the answer to that one.
No worries. And then another question about what's the largest size of the burners or the hobs, and do they accommodate pans that are smaller than usual? And in this unit, is there a way to link two burners to accommodate a large pan or griddle? So is there a bridging functionality? I guess the configuration of the cooktop itself is a question.
Yeah, so the cooktop is a 12-inch, a 10-inch, and then a couple little 8-inch ones in the back on this. When you talk about bridging, it's just making sure that there's like a continuous inductor presence beneath them. The two in the back are very much adjacent, and if you place a small griddle across them and give it a moment to heat up, it acts like a great little cast iron griddle would. If you were cooking on any other like cooktop, it is not like a fully like bridged experience, but you can absolutely lay a cast iron griddle across a couple of inductors if you like.
Sure.
And also power 4,000, 3,200, and 2,1800s if people are into the wattage of their inductors.
Sure. Yeah. How much power can actually go into each one?
Yeah.
Like a power question also, I think you've talked about it briefly, but the outlet on the unit, where is it located, and it can be used to power external appliances?
Yeah. So actually on this one, it's in the back, but you can see a little hole we've been cut, an auxiliary hole to test out putting them up here in the back here. So this is a hole where you could potentially plug in as well. We're exploring that rather than having it in the back because the back is relatively inaccessible. And so, but yeah, having it in a position where you could, access it quickly in the case of a power outage.
Great. So that can be used to power anything that you would use for counter appliance, or like a
Totally. And I mean,
for
like, if your fridge is right next to your oven too, you could plug in your fridge and just have it be part of that load shifting experience all the time if you want. That's user choice. Or, you can just use it in the case of a blackout. The power's out, you can plug something into it, whatever's important to you, right? If that's your fridge, do your fridge. If that's, if you are a college football fanatic and your team is playing and you got to get the TV plugged into it, go for it. It's there to provide that kind of resilient electrification experience that you can get only with a product like this, only with an energy storage equipped appliance.
Amazing. And that phrase being so important.
Well, I mean, I think it's a different category, right? It's not,
Sure,
this is
yeah.
not just an induction range, right? Like it provides, because the answer on how do you install an induction range is that incredibly complex answer, right? And it costs hundreds of dollars to even find out. How do you install an energy storage equipped induction range? And the answer is easy, you plug it in, right? And then plus the benefits of resiliency and load shifting, you're talking about a package of benefits that is really not comparable to just an induction range.
Amazing. The question, I saw another one that's actually kind of interesting is, are you guys exploring the ability to retrofit existing non-energy storage equipped induction ranges, like with a retrofit kit or anything of that nature?
Yeah, so we have, and look, our first ones are effectively, we're buying well-built chassis and taking the guts out of them and using those chassis. But retrofitting other ones, I think the bespoke nature of having to do different models would be cost prohibitive. It would be a collector's item, right? It would be like like rebuilding a classic car in terms of cost. It would be a labor of love. And in terms of what we're building as a business, not really a scalable business.
Sure. Question on the app. Is there an app? I didn't know if there was an app. But
we are not launching with an app.
Sure.
On the initial ones, they are knobs and on oven controls. You can set timers so the oven can start later and all that fun stuff. But we are not launching with an app. We're focused on making the user control experience something that is easy and familiar, something that you can just walk up and turn the knob and that's what your experience is, rather than trying to make overly sophisticated user control experience.
Sure. Part of the question was on the battery storage. How do you know how much battery you have? What's the user experience there, and how do you check that?
Yeah, simple battery status lights. So you know, the 100, 75, 50, 25 nil, or so just I would say a fairly standard what's your battery at.
Sure. And that's located directly on the battery unit itself.
Yeah, it's on the battery unit. I mean, the reality is, I mean, you can take a look at them if you want. This one actually, I think, has it detached and like over here, because we have this one is plugged into a monitoring computer that is tracking exact usage on its performance. But yeah, it's like it's in the battery drawer, so you can just take a you can take a look at it if you need to. The reality is we want that experience to be invisible for most people, right? Like that is not something that we experience as having to look at the state of energy storage. It's a question of you can if you want to, but you shouldn't need to.
Sure. Great. So looking at the time, we'll probably do one or two more questions. Thank you so much for your endurance, as there's so much curiosity.
Yeah, no dramas, no dramas.
Paul, would you mind coming off mute? Are you interested in coming off mute to ask your question around the building codes?
Yeah. Okay, so I've just been dealing with this in another area, and there's a lot of confusion. So I've been drilling down into it. Both national codes, both electrical and fire codes, trigger, I believe, at a 1 kilowatt-hour battery storage for on-site energy storage. Now, this battery is not bidirectional as home energy storage.
That's right.
So, but I'm not sure where it fits within those codes and if you've looked at that.
Yeah, it does not trigger anything because it is not a bidirectional battery. It is not pushing power back out to your panel. It is it's like a backup battery that you could buy and plug your TV into. That's a fairly common, set of products that you basically, the EcoFlows, the Jackeries of this world, you can buy, a 1 or 2 kilowatt-hour battery with an inverter built into it, and it's just a big heavy box that you can plug into. This is more analogous to that in terms of its experience, because this is not backfeeding to the grid, unless you get it set up on a dedicated 240. Now the charger on this can run on 240 as well. It doesn't have to be plugged into 120. And if you have that plugged into a dedicated and can backfeed, like that's a thing you could do. But then again, you're dealing with, as you say, you're having to deal with the permitting and the code requirements around that. But that's that is a thing that a licensed electrician would have to do.
I will say licensed electricians have been significant sources of misinformation. So you might want to provide some clarity on that.
That is not something that I would say we are not selling to that use case right now. So I mean, I appreciate that when people come to us and that is the use case that they want to get into, we'll provide that optionality. But that's not the use case that we're selling into right now.
I understand that. What I'm saying is information from contractors about energy storage in batteries on site may cause problems.
Yeah. No, absolutely. And that, I mean, when we get to people, when we start selling into that situation, it is in the same way that we're going to be holding our customers' hands to make sure that they get all the rebates, making sure that their experience on installation is perfect. I mean, we're doing these installs ourselves in the beginning. So making sure that they get the right experience.
Amazing. Awesome. So looking at the time, I will say, let's wrap it up. But if you have more questions, we'd love for you to engage with Channing Copper Street Company yourselves. And well, then would you be comfortable if we put your email in the chat?
Absolutely. I'm Weldon at Channing Copper, WELDON at channingcopper.com. Drop me a line, say you're on this webinar. I'd love to talk to you. Hit me up on LinkedIn as well. Weldon Kennedy there. Would love to say hi and hear what everyone on this call is doing to make people's lives better and decarbonize our lives. Because I mean, there's a couple hundred, 160, I don't know how many people on here, right? But you guys are all probably doing super exciting stuff. And I really want to meet you too. I feel a bit silly that I'm the one up here talking, because you probably all have very interesting stories and doing exciting work. So I would love to hear from you, please.
Absolutely. Great audience. But thank you so much to you for your time and for all the work you're doing to get all of this going. It's all needed. So big round of applause for Weldon. Thank you so much for your time. And
thanks everyone.
Thank you everyone for joining.